Okay, students, today we have to start our discussion with the displacement reactions. Okay, in the previous lecture, we have already seen the combination type of reactions and decomposition reactions. For quick recall, I can tell you the combination reactions are the reactions in which two or more smaller molecules combine to form a bigger molecule, right? And just opposite in the case of decomposition reactions, a bigger molecule was going to be broken down into the smaller molecules, and decomposition reactions were further categorized into three categories: thermal decomposition, electrolytic decomposition, and photolytic decomposition. We have seen all the examples, all the three. Okay, and those students who have not gone through the previous lecture, it's my suggestion first to go through the previous lecture, then switch to this video. Okay. Yeah. So this is the time to discuss about the displacement reactions. Those reactions in which one element takes the place of another element in a compound are known as displacement reactions. Okay. Displacement, as you can understand just by the name, that some element is going to displace the other, okay, and taking its place. So it will always happen in chemistry as well as in nature as well as in your life. A more reactive element, a more reactive substance, as a more reactive person can replace you, right? So in case of metals, a more reactive metal will replace the metal from the salt. Okay, for example, we are having CuSO4. Zinc is more reactive than copper. So if we will put a zinc strip in the copper sulfate solution, it will form the zinc sulfate and copper. How can we observe this reaction? Because copper sulfate is blue in color. When we will put a zinc strip into it, copper will be deposited in its strip, and the solution of the color of the solution will turn colorless. Slowly it will fade and then it will turn colorless. Understood? This is all about the displacement of copper by zinc. Students, this reactivity, how will we come to know that which element or which metal is more reactive or which non-metal is more reactive? This we decide on the basis of electrochemical series, which you will be exposed to in class 12, or something about this will be told in the redox reaction class 11. But for time being, I am telling you some elements in a series to learn as per their reactivity. Okay. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen. Below this we are having copper, mercury, gold, platinum. Okay. So this is the decreasing order of your reactivity series. It means potassium is most reactive. After that, we are having sodium, then we are having calcium, then magnesium, then aluminum, then zinc. In this series, you can see copper ke comparison mein your zinc is more reactive. Okay, that's why from the copper sulfate solution, zinc is replacing copper. Okay, so a more reactive metal will displace a less reactive metal from its salt solution in the displacement reaction. Fine. This is about the displacement reactions. You all are suggested to note down this. Displacement reactions. We are discussing, and we have just discussed about the example of copper sulfate and zinc, right? The similar reaction will be observed in case of copper sulfate with magnesium, because magnesium is also more reactive than copper. So it will displace copper from copper sulfate solution to form magnesium sulfate, and copper metal will be deposited. Okay, in this reaction also you will observe that the blue color of the solution fades slowly, and finally you will get a colorless solution of MgSO4, and a reddish brown metal will be deposited in the bottom of the test tube or on the metal strip, depending upon what you are using. Okay. Other example can be copper sulfate with iron. You again know that iron is more reactive than copper. What will happen? In this situation, the blue color solution of copper sulfate will turn into the green color solution of iron sulfate. Why? Because iron sulfate is green in color. Okay. Understood? What will happen in the reverse case? Just guess, students. Suppose if I am having iron sulfate plus copper, what will happen? In this case, no reaction will take place. Why? Because copper is less reactive. Okay, less reactive metal cannot displace any element from its salt solution. Okay, only a more reactive metal can displace the salt solution. Only a more reactive metal can displace another metal from its salt solution. Suppose we are having magnesium in place of copper, then again we will get the colorless solution of magnesium sulfate and iron will be deposited. Understood? Why? Because magnesium is more reactive than iron. Fine. I hope the concept is clear to all of you for the displacement reaction. Let's move further. Here are few other examples. Copper chloride. Copper 2 chloride it is, having a green solution. When we will put a bluish gray color metal, that is lead, then a colorless solution of lead chloride will be formed, plus red brown metal copper will be deposited. Listen carefully, students. All those reactions in which any change in color, any evolution is gas, or any change in heat is taking place become automatically important for your board examinations. All right. Another example we can have, we are having the colorless silver nitrate and putting copper into it. Copper is more reactive than silver. Then what will happen? Copper nitrate will be formed and silver will be uh, replaced from its salt solution, displaced. Okay. Iron with HCl, hydrogen से पहले अभी मैंने reactivity series आपको दिखाया था, and you must have seen that hydrogen was less reactive than iron. Then what happened? Hydrogen को displace कर रहा है iron to form iron chloride, and hydrogen gas will be liberated here. Magnesium plus HCl, similar reaction will be there. Sodium plus water, sodium hydroxide and hydrogen gas will be liberated. हाइड्रोजन गैस का टेस्ट कैसे करेंगे स्टूडेंट्स आप लोग? ये जो गैस रिलीज हो रहा है इसका टेस्ट करने के लिए पुट अ बर्निंग स्प्लिंटर नियर द माउथ ऑफ द टेस्ट ट्यूब. ओके, द इवॉल्विंग गैस विल बर्न विद पॉप साउंड. फाइन. हाइड्रोजन गैस का ये टेस्ट रिएक्शन है दैट इट बर्न्स विद पॉप साउंड. अंडरस्टैंडिंग व्हाट आई एम सेइंग? ऑलराइट. Chlorine gas reacts with potassium iodide solution to form potassium chloride and iodine. So this is it for displacement reactions. We can, yes, some more reactive non-metal can also displace and give the displacement reaction, displace a less reactive non-metal and give the displacement reaction. For that, let me show you one example. Yeah, see here, a chlorine molecule which is a more reactive than non-metal than iodine is displacing iodine and forming the salt solution of chlorine. Understood? Forming a salt of chlorine. Wait a minute. All right. Other example, you can see copper oxide with magnesium gives magnesium oxide and copper. Let's move on. Ferric oxide and aluminium. This reaction is of immense importance. Okay. because this is used in thermite welding. Okay, this reaction is used for the welding purpose. आयरन ऑक्साइड रॉड्स आप लेते हैं और एल्यूमिनियम के साथ उन्हें जब हीट करते हैं, सो व्हेन आयरन ऑक्साइड इज हीटेड विद एल्यूमिनियम पाउडर, देन एल्यूमिनियम ऑक्साइड एंड iron metal is formed. The temperature for this reaction is too high that iron thus formed is formed in the molten state. Okay, पिघला हुआ फॉर्म होता है. सो अगर कहीं पर ब्रेकिंग है राइट आयरन के ऑब्जेक्ट्स में, तो वी कैन यूज दिस रिएक्शन फॉर द वेल्डिंग पर्पज एंड वी आर यूजिंग ऑल्सो. This is all about the displacement reactions. Let's move forward to see the double displacement reactions. Beta, double displacement reactions are those reactions in which interchange of ions takes place. Okay, for example, you can see AgNO3 you are having reacts with NaCl to give AgCl and NaNO3. यहाँ पर exchange of ions हो रहा है. सिल्वर के साथ नाइट्रेट था, that is going with chlorine. Okay, क्लोराइड आयन को ले लेगा और सोडियम एंड नाइट्रेट will be formed. Sodium nitrate. Understood? So interchange of ions takes place. The general representation for this reaction is AB plus CD gives AC plus BD. Getting me? So this is the general representation for these reactions. Interchange of ions is taking place in most of these reactions. I'm saying not all, just most of these reactions में आपको precipitate formed देखने को मिलेगा. ठीक है, सो यहाँ से आपको precipitate का कलर भी लर्न कर लेना है. फॉर एग्जाम्पल AgNO3 plus NaCl gives AgCl. AgCl का white precipitate आएगा and NaNO3 in the aqueous solution will be left. Other reaction you can see BaCl2 plus Na2SO4, barium sulfate का white precipitate मिल जाएगा आपको. This is a test reaction, all right. And barium chloride with copper sulfate, barium sulfate का white precipitate मिल जाएगा आपको. Copper sulfate with hydrogen sulfide, so यहाँ से copper sulfide का black precipitate आएगा. कलर चेंज हो रहा है, ध्यान रखेंगे, all right. Sorry, CuS copper sulfide black precipitate है इसका. Aluminium chloride with ammonium hydroxide will form aluminium hydroxide white PPT. Aluminium hydroxide का white precipitate होता है बेटा, understanding, and ammonium chloride will be formed. Lead nitrate with potassium iodide will form the lead iodide yellow precipitate, right? Yellow color का precipitate मिलेगा आपको यहाँ पर, और silver nitrate will be formed. Apart of this, NaOH plus HCl gives NaCl plus HOH. Okay, this is a reaction in which no precipitate is formed. That's why I was saying in most of the reactions you will see the formation of the precipitate, but not in all reactions. This is a neutralization reaction. Acid plus base gives salt and water. In detail, we will study about this in the chapter acid, bases and salt. All right. There are some example questions you people can go through. Then we are going to have oxidation and reduction reactions. See students, before studying the oxidation reduction reactions, you must have the idea that what is oxidation and what is reduction. So whenever addition of oxygen is taking place, it is oxidation. Removal of hydrogen is oxidation. And sorry students, just wait a minute. Yeah. So we are discussing the oxidation and the reduction. Addition of oxygen is oxidation. Removal of hydrogen is oxidation. On the other hand, addition of hydrogen is reduction. Removal of oxygen is reduction. Okay. And the best way to understand all these is electronic concept. So addition of electron is reduction and removal of electron is oxidation. Okay. Removal of electron, oxidation. Addition of electron, reduction. Now we have to see some of the redox reactions. Oxidizing agent is what? One which brings about oxidation is called oxidizing agent. एंड जो ऑक्सीडेशन करवाएगा इट इज प्रूवन दैट उसका खुद ही रिडक्शन होगा, राइट. सो वन विच इज ऑक्सीडाइजिंग एजेंट इज undergoing reduction itself, okay, and one which is reducing agent is undergoing oxidation itself. Clear? Reducing agent का हमेशा oxidation होता है और oxidizing agent का हमेशा reduction होता है. Make it a note and learn it. Let's see the example. We are having copper oxide. सी कॉपर ऑक्साइड से आपने कॉपर फॉर्म किया इस रिएक्शन में, रिमूवल ऑफ ऑक्सीजन दैट इज ऑक्सीडेशन. क्लियर? एंड हाइड्रोजन से आपने वाटर फॉर्म किया है, एडिशन ऑफ ऑक्सीजन हो रहा है, दिस इज ऑक्सीडेशन. कॉपर ऑक्साइड टू कॉपर रिडक्शन, हाइड्रोजन टू वाटर ऑक्सीडेशन, राइट. सो कॉपर ऑक्साइड जिसका रिडक्शन हो रहा है इट मींस कॉपर ऑक्साइड इज ऑक्सीडाइजिंग एजेंट, एंड हाइड्रोजन जिसका खुद ऑक्सीडेशन हो रहा है इट मींस हाइड्रोजन इज रिड्यूसिंग एजेंट. फाइन बेटा, you will get the question that you have to write oxidizing agent, reducing agent, substance oxidized and substance reduced, right? So substance reduced and oxidizing agent are same, and substance oxidized and reducing agent are same. Fine. As you can see here, substance oxidized, hydrogen, reducing agent, hydrogen, substance reduced, copper oxide, substance reduced is copper oxide, and oxidizing agent is also copper oxide. In this way you can have many other examples. See, it is explained, and the other examples are H2S plus chlorine gives HCl. Then zinc oxide and carbon, zinc plus carbon monoxide, manganese oxide plus HCl gives manganese chloride, and chlorine plus water, copper plus oxygen give copper oxide, copper oxide plus hydrogen gives copper plus hydrogen plus water. So all these reactions are the examples of oxidation and reduction type of reactions. Effects of oxidation and reduction reactions in everyday life we'll take in the next lecture, and we'll also take the oxidation and reduction reactions in great detail. Till then, this is your homework to go through it. Okay? Thank you, class. Keep learning, keep studying, and stay connected and stay healthy. Thank you.